Okay, so now we're going to work through a specific example here of the second derivative test. So this is example number 1. So here's the function, negative x to the third plus 7x squared minus 15x. We're going to use the second derivative test to locate and identify, so say where they are and what type they are, locate and identify the relative extrema. We're going to express the answers as either a maximum or a minimum at x equals number, and either a maximum or a minimum at x equals a specific number. So let's go through this, this particular function here. What we're going to need is the first derivative. So that's negative 3x to the second plus 14x minus 15. We need the type 1 critical values from this derivative. We need the type 1 critical values from the first derivative. Remember that there are no type 2 critical values because this is a polynomial, and even if you had type 2 critical values, you could not use the second derivative. You're not allowed to use the second derivative test to analyze type 2 critical values. But all we have are type 1. So we're good to go here. So we need to find the the critical values, right? We need the derivative set to 0. And let's see, I'm going to multiply both sides by negative 1 to clear this negative out. So this implies 3x to the second minus 3x to the second minus 14x plus 15 is equal to 0. That actually implies, that factors. That implies 3x, x, this is x rather. This is 3, this is 5, that's negative, that's negative. It's not too hard to conclude that's the correct factoring here. And so what we generate out of this, the two solutions are 5/3 and 3. So we have two critical values. One possibility for C is x equals 5/3. One possibility for C is x is equal to 3. And so now the question is, how do we analyze this? Well, the second derivative test means, well, of course, we need the second derivative. So that's not the challenge. The second derivative is the derivative of this. That's negative 6x plus 14. All right. And we need to evaluate the second derivative at each of these individual critical values. So we need second derivative evaluated at 5/3, and we need the second derivative evaluated at 3. Well, at 5/3, this is negative 6 times 5/3 plus 14. Top times top, bottom times bottom, that's negative 30 over 3. It's not too hard to show this is negative 10 plus 14, which is 4. All right? Now, what does the second derivative test tell us? If the second derivative evaluated at that critical value is greater than 0, the specific number is irrelevant. All we need to know is whether it's greater than, less than, or equal to 0. In this case, 4 is greater than 0, so we know we have a relative, you tell me. I can't hear you because it's through a video, but if it's greater than 0, remember the second derivative test is the opposite. Greater than 0 means there is a relative minimum. All right? Second derivative evaluated at 3, that's negative 6 times 3 plus 14, negative 18 plus 14 is negative 4. This is a coincidence. Don't assume this occurs every time. This is less than 0. Remember, it is opposite. So less than 0 means we have a relative maximum. And so express your answer as, so we have a relative minimum at x equals 5/3. We have a relative maximum at x equals 3. So use the first derivative to find the critical values, use the second derivative to analyze those critical values. If the value is greater than 0, the second derivative evaluated is greater than 0, its opposite, it's a relative minimum. If the second derivative evaluated is less than 0, its opposite, it's a relative maximum. So we have relative minimum, x equals 5/3, relative maximum, x equals 3. If for some reason you actually needed the coordinates, 5/3 comma number, you would take 5/3, place it into the original function, and evaluate that. That's going to be a bit of a hassle here. It could be done, particularly if you had a nice calculator with you. And similarly, if you needed 3 comma number, you could take 3, substitute it into here, and get whatever number you needed to have. For our purposes, it suffices to express your result as x equals value and x equals value.